For centuries, Betelgeuse, one of the most recognizable stars in the night sky, has captivated the imagination of astronomers and stargazers alike. Nestled within the Orion constellation, this massive red supergiant is nearing the end of its life, and scientists have long speculated about its eventual fate, a spectacular supernova explosion. Recent observations by the James Webb Space Telescope have unveiled unexpected and concerning details about Betelgeuse's imminent demise. These revelations could have profound implications, not just for our understanding of stellar evolution, but also for Earth and its cosmic neighborhood. Betelgeuse, a red supergiant located about 642 light-years from Earth, has long captivated astronomers and stargazers alike due to its sheer size, brightness, and relative proximity to our planet. This cosmic giant, nestled within the constellation Orion, is one of the most studied stars in the night sky, offering a unique opportunity to explore the mysteries of stellar evolution. Its immense scale, roughly 700 times the diameter of the Sun, makes it one of the largest stars visible to the naked eye, while its pulsating brightness provides a dynamic and ever-changing spectacle. What makes Betelgeuse particularly intriguing is its status as a red supergiant in the late stages of stellar evolution. Having exhausted the hydrogen fuel that sustained it for millions of years, the star is now fusing heavier elements in its core, a process that signals its impending demise. This phase is fleeting on a cosmic timescale, making Betelgeuse a rare and valuable case study. Its proximity allows astronomers to study it in extraordinary detail, providing insights into the processes that govern the life cycles of massive stars. Betelgeuse's current state of instability has heightened scientific interest. Over the past few years, it has exhibited unusual behavior, such as sudden dimming episodes and irregular fluctuations in brightness, suggesting significant changes in its internal structure. These signs point to the possibility that Betelgeuse is nearing the final stages before it collapses under its own gravity and explodes in a spectacular supernova. Such an event would not only be visible from Earth, but would also provide an unprecedented opportunity for real-time observation of a massive star's death. Betelgeuse serves as a cosmic laboratory, offering humanity a front-row seat to one of the most dramatic phenomena in the universe, a supernova explosion that will reshape our understanding of stellar life cycles. This celestial event, when it occurs, will be visible even during the day and will briefly outshine the entire Milky Way galaxy. Yet, as the James Webb Telescope peered deeper into the heart of this dying giant, it found signs that its final act might not unfold as anticipated. The first hint of something unusual came in late 2023, when Betelgeuse exhibited a series of unexpected dimming and brightening episodes. While variability in Betelgeuse's brightness isn't uncommon, the patterns detected by the Webb telescope were unprecedented in their intensity and irregularity. Astronomers initially attributed these fluctuations to massive ejections of stellar material, a phenomenon observed in Betelgeuse's past. However, further analysis revealed that these events were accompanied by significant disruption in the star's outer layers, suggesting a much more volatile internal state than previously thought. One of the most alarming discoveries was the detection of massive gravitational waves emanating from Betelgeuse. Using its advanced spectroscopic instruments, the James Webb Telescope identified these waves as evidence of core instability within the star. Gravitational waves, ripples in space-time caused by massive movements of matter, are not commonly associated with stars like Betelgeuse. Their presence indicates that the star's core is undergoing rapid changes, possibly linked to the final stages of nuclear fusion. This instability raises concerns that Betelgeuse's supernova could occur much sooner than initially predicted. Adding to the intrigue, the Webb telescope detected unusually high concentrations of heavy elements, such as silicon, iron, and nickel, in the material ejected from Betelgeuse's outer layers. These elements, typically produced during the final stages of a star's life, are hallmarks of supernova precursors. The sheer abundance of these materials suggests that Betelgeuse is already in the process of shedding its outer envelope, a phenomenon known as pre-supernova mass loss. This process not only accelerates the star's demise, but also affects the dynamics of the eventual explosion. Perhaps the most concerning aspect of the James Webb Telescope's findings is the potential impact of Betelgeuse's explosion on our solar system. Although 642 light-years might seem like a safe distance, the energy released by a supernova of Betelgeuse's magnitude could have far-reaching consequences. Scientists estimate that the explosion would release a burst of gamma radiation capable of impacting Earth's upper atmosphere. While not an extinction-level event, this radiation could disrupt satellite communications, damage electronic infrastructure, and even alter weather patterns temporarily. Furthermore, the cosmic debris from Betelgeuse's supernova could eventually reach our solar system. Although this process would take tens of thousands of years, the influx of high-energy particles and interstellar material could affect the heliosphere, the protective bubble formed by the solar wind. Changes in the heliosphere could expose the planets, including Earth, to higher levels of cosmic radiation, with potential implications for life and technological systems. The James Webb Space Telescope's observations have also provided valuable insights into the timeline of Betelgeuse's explosion. By analyzing the star's light spectrum, scientists have identified unique signatures indicative of the core's final fusion processes. These signatures suggest that Betelgeuse is entering the silicon-burning phase, the last stage before a supernova. Once this phase begins, a star typically has only weeks or months before it collapses under its own gravity, triggering a cataclysmic explosion. Despite the alarming nature of these discoveries, astronomers emphasize that Betelgeuse's impending explosion is a rare opportunity to study the death of a massive star in unprecedented detail. Unlike most supernovae, which occur in distant galaxies, Betelgeuse is close enough for telescopes like Webb to observe the event in real time. This proximity will allow scientists to test and refine their models of stellar evolution and supernova mechanics, shedding light on one of the most dramatic phenomena in the universe. Betelgeuse's eventual supernova explosion will not merely be a cosmic spectacle, but a transformative event for the interstellar medium, reshaping its chemical composition and paving the way for the birth of new celestial bodies. When a massive star like Betelgeuse reaches the end of its life, it undergoes a dramatic and violent collapse, triggering a supernova explosion of unparalleled intensity. This process is not just destructive, but also profoundly creative, as it releases vast quantities of heavy elements into the surrounding space, elements that are crucial for the formation of planets, moons, and even the foundations of life itself. In the extreme heat and pressure of a supernova, atomic nuclei undergo fusion reactions that create heavier elements like gold, silver, platinum, uranium, and other metals. These elements, too heavy to be formed in the cores of most stars during their lifetimes, are born in the intense energy of a star's final moments. The explosion then ejects these newly formed elements into the surrounding interstellar medium at incredible speeds, enriching it with the raw materials necessary for the formation of new stars, planetary systems, and even organic compounds that might one day lead to life. The enrichment of the interstellar medium by Betelgeuse supernova will have far-reaching implications. The materials expelled during the explosion will mix with existing clouds of gas and dust, enhancing their chemical diversity. Over time, these enriched regions of space may collapse under their own gravity, forming dense molecular clouds that act as nurseries for new stars. These new stars, in turn, may be surrounded by protoplanetary disks containing the heavy elements needed to form rocky planets like Earth. Without supernovae such as Betelgeuse, the universe would lack many of the essential elements that form the foundation of the physical and biological structures we see today. Beyond the creation of planets, Betelgeuse supernova will contribute to the dynamic evolution of galaxies. Heavy elements play a crucial role in cooling interstellar gas, a process that facilitates the formation of new stars and influences the life cycle of entire galaxies. The radiation and shock waves from a supernova also compress nearby gas clouds, potentially triggering additional rounds of star formation in surrounding regions. In this sense, Betelgeuse's explosive demise will not only enrich the galaxy chemically, but also stimulate its ongoing growth and renewal. The idea that Betelgeuse's death is not just an end, but also a beginning, is deeply profound. The very atoms that make up our bodies, such as the calcium in our bones and the iron in our blood, were forged in ancient supernovae billions of years ago. The death of stars like Betelgeuse is what makes life possible, ensuring that the universe is continually seeded with the elements needed for the emergence of complex systems. Its explosion will mark another step in this grand cosmic cycle, connecting us to the stars in the most literal and elemental sense. Betelgeuse supernova reminds us of the interconnectedness of all things in the universe. From the death of a single star comes the potential for countless new beginnings, as its remnants spread across space to form the building blocks of future worlds. This profound cycle of death and rebirth underscores the dynamic nature of the cosmos, where destruction paves the way for creation and endings are often the prelude to new and extraordinary beginnings. The James Webb Telescope's findings have sparked a flurry of activity in the scientific community. Observatories around the world are now focusing their instruments on Betelgeuse, monitoring it for further signs of instability. Meanwhile, researchers are working to model the potential impact of the star's explosion on Earth and its surroundings, ensuring that we are prepared for any effects it might have. As we stand on the cusp of witnessing one of the universe's most awe-inspiring events, Betelgeuse serves as a poignant reminder of the dynamic and ever-changing nature of the cosmos. Its eventual explosion will not only illuminate the night sky, but also deepen our understanding of the forces that shape the universe.